Okay, so question number 3, right? What is the magnitude of gravitational force? So calculate gravitational force F. So the equation is F is equal to capital G m divided by d square. So we need the mass of object 1 and mass of object 2. So here, what is the gravitational force between the Earth? So object 1 is Earth. So this is Earth. And 1 kilogram object on its surface. So this is the object. This is the object. This object is very, very small, right? Because this mass is 1 kilogram. What is the mass of Earth? So the mass of Earth is given 6 into 10 raised to 24 kilogram. Okay. What is 6 into 10 raised to 24 means? 6 into 10 raised to 24 means 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, right? So this is 6 into 10 raised to 24 means how many zeros? 24 zeros, right? So this is the mass of the Earth in kilogram. And what is the mass of the object? 1 kilogram, very small. Okay, just compare this with the 1 kilogram. So this is very, very small, right? When we compare the mass of the Earth. So next we need D. So what is actually D? D means, as per Universal Law of Gravitation, D is the center to center distance, right? So this distance is this distance is D, right? From center of object 1 to center of object 2. This is distance D. But here the object is here and the mass is very small. So you can take this distance as the radius of the Earth that is given. Okay, what is the radius of the Earth? What is the radius? Radius means half of the diameter, right? So this is the radius. So we can take this D as the radius of the Earth. So the radius of the Earth is given 6.4 into 10 raised to 6 meter. So I can write the equation is equal to capital G m divided by r square. I can replace this D with r square, where r is the radius of this Earth. This is r. Okay, why? Because this is very, very small. This is the object is only 1 kilogram. So the object is very, very small. So now you can solve the problem. So F is equal to, okay, what is the value of G? What is the value of G? 6.673 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2, right? So I'm writing this as 6.6, so I am taking 6.7. Okay, 6.7 into 10 raised to minus 11 into what is capital M? Capital M means mass of the Earth in kilogram. So 6 into 10 raised to 24 into small m is mass of the object 1 kilogram, the whole divided by what is the radius of the Earth? Radius of the Earth is 6.4 into 10 raised to 6. 6.4 into 10 raised to 6. Into, so this is r square, right? So that means 6.4 into 10 raised to 6, because this is r square. So next, a raised to m into a raised to n, right? What is a raised to m into a raised to n? A raised to m plus n. So so what is 10 raised to minus 11 into 10 raised to 24? That is equal to 10 raised to minus 11 plus 24. So that is equal to 10 raised to, so 24 minus 11, 3, 1, 30. 10 raised to 30. So this is equal to, so f is equal to 6.7 into 6 into 1 into 10 raised to 13 divided by 6.4 into 6.4 into, this is 10 raised to 6 into 10 raised to 6, that is 10 raised to 12. 10 raised to 6 into 10 raised to 6 is a raised to m into this law of exponent you can use. A raised to m into a raised to n is equal to a raised to m plus n. Then next, this is equal to, then you can apply the next one, a raised to m divided by a raised to n equal to a raised to m minus n. So 10 raised to 13 divided by 10 raised to 12 is equal to 10 raised to 13 minus 12. That is equal to 10 raised to 1. So 10 raised to 1 is 10. So you can write f is equal to, so f is equal to 6.7 into 6 into 10 divided by 6.4 into 6.4. Next, you can change the decimal. So you can multiply with the, so in the numerator 6.7, so one place. So I will multiply with the 10 into 6 into 10. And the denominator 6.4 into 6.4. So that means for the first number 6.4, I will multiply 6.4 into 10 to change this decimal into 6.4 into 10. That means I multiplied 10 into 10 in the denominator. So I have to multiply 10 into 10 in the numerator also. So f is equal to, so 6.7 becomes 67 into 67 into 6 into 10 into 10 divided by, denominator will be 64 into 64. So 67 into 6, 67 into 6 is 402 into 100. That means 20 divided by 64 into 64. 64 into 64 is 4096. So 40200 divided by 4096. That is equal to 9.8. 9.8 Newton. So the answer is 9.8 Newton. So the answer is force is equal to 9.8 Newton, right? Force is equal to 9.8 Newton. And the unit of this is gravitational force, and the force is 9.8, and the unit is Newton. So that's all about this topic, law of gravitation, universal law of gravitation. So what is universal law of gravitation? Every object in the universe attracts every other object with a force, and the force is equal to directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This law is called a law of gravitation, and this law is applicable to any object, all the objects in the universe. That's why this law is called a universal law of gravitation. And what is the unit of force? The unit of force is Newton. The unit of force is Newton. Okay. So the next topic is free fall. Free fall. For example, this is my Earth. Okay. This is my Earth. This is the surface of the Earth, and we have a object. We have an object here at a certain height. This is at a certain height. This is the object. So this object, when I am releasing this object, what happens? This will fall towards the Earth, right? Because of the gravitational force. Because Earth is object, right? As per the universal law of gravitation, every object in this universe attracts every other object. So because of the gravitational force, Earth is attracting this object. So this object will fall towards the Earth. And we already discussed in chapter number 2, that is to move an object, to change the state of an object, we need an unbalanced force, right? As per Newton's first law, to change the state of an object, we need an unbalanced force. But check here, here there is a motion, right? Here there is a motion, but there is no force I am applying. There is no force. Here the only force is the gravitational force. Okay, because the Earth is attracting this object. And when I am releasing this object is moving, fall towards the Earth only because of the gravitational force. The object is moving. We already studied, as per Newton's first law, to change the state of an object, we need an unbalanced force. Okay, but here, see this. Here, there is no other forces acting on this object. The only force is the gravitational force. Okay, this motion is called a free fall. Okay, so what is free fall? The object is moving only because of the gravitational force. No other force. Here, no other force is acting on this object. So this motion, the object is moving. This motion is called a free fall. So from the name, you can see it's free. Free means no other forces acting. No other forces acting. So free fall, freely falling. The object is freely falling towards the Earth because of the gravitational force. This is what is called a free fall. So once again, this is the Earth, and this Earth is the surface of the Earth, and this is the object. and this object is falling towards the Earth only because of the gravitational force. That means gravitational force only gravity influence the motion. There is no other force acting on this object. So this type of motion is what is called a free fall. This type of motion is called a free fall, where the only force is gravitational force. No other force is acting. Okay, so let's take an example. Again, this is the Earth, surface of the Earth. So I'm taking a stone and I'm throwing stone upwards like this. I'm throwing stone to a particular height. So what happens? The stone will rise, it slowly move, and at one particular point, the stone will reach here, right? The stone will reach here. Then what happens? The stone will reach here, and then this stone will falls back. This stone falls back. Why? Because the Earth is attracting. As per the law of gravitation, universal law of gravitation, the Earth is attracting the object. There is a force of attraction. F is equal to capital G m divided by d square. So Earth is exerting this force to this object. Because of that, when you throw a stone upward direction, so after some time it will reach a certain position, and then the object will falls back because the Earth is exerting a force to this object. Because of that force, the stone is falls back to the Earth. That means the Earth gravity pulls it down all the times. This is what is called as acceleration due to gravity. So that means here there is a change in velocity, right? So what is the equation of acceleration? What is the equation of acceleration? Acceleration A is equal to V minus U divided by T. This is the equation of acceleration. That means when I am throwing this stone upwards, that means there is an initial velocity, then the final velocity is zero. Okay, I'm throwing the stone with an initial velocity, that means U. Then the stone will reach a particular point. Then at this point, the final velocity is equal to zero. So that means there is V minus U. So wherever there is a change in velocity, we will define the term acceleration. Acceleration is equal to V minus U by T. So here there is a change in acceleration. And this acceleration is only because of the gravity. There is no other force. So this acceleration is only because of gravity, is what is called acceleration due to gravity. And we will denote this using the small letter g. So small letter g is acceleration actually. This is acceleration. This is acceleration. But this acceleration is due to gravity. This acceleration is due to gravity. And the unit of, we already know that what is the unit of acceleration? Unit of acceleration is meter second raised to minus 2. The unit of gravity is also same because gravity is acceleration, g is acceleration due to gravity, and the unit is also same, ms raised to minus 2. ms raised to minus 2. Okay. Next, we are going to calculate what is the value of g. So from Newton's second law, we know that Newton's second law, from Newton's second law, we calculated F is equal to m into a, mass into acceleration. Then we know that universal law of gravitation, from universal law of gravitation, F is equal to capital G, capital M, small m divided by d square. Okay. So we have two equations. This is equation number 1. This is equation number 2. and check the LHS, both are same. So here the LHS is F, here the LHS is F. So I can equate the RHS. So here the RHS is M into A. So I can write M into A is equal to capital G, capital M, small m divided by D square. So this is small m cancelled. This m cancelled. So I can write this A, I can write, I will replace this A with the G because here the acceleration is because of gravity only. So I can replace this A with the G. So this G is equal to capital G, capital M divided by D square. So D square I can replace with the R square. R means the radius of the earth. R is the radius of the earth. This is the R. R is the radius of the earth. Okay. And the value of G is equal to, and we know that what is the value of G? So the value of G is equal to 6.673 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. So 6.673 into 10 raised to minus 11 into capital M. Capital M is the mass of the earth. Six into 10 raised to 24 kilogram divided by radius of the earth is 6.4 into 10 raised to 6 meter. When you substitute this and solve this, we will get the answer of G as 9.8. G is equal to 9.8. And the unit is, this is acceleration. The unit is meter second raised to minus 2. Meter second raised to minus 2. Okay. So once again, first you write the Newton's second law. Newton's second law is mass into acceleration. Then universal law of gravitation, F is equal to capital G, capital M, small m divided by D square. Then I will replace this D square with R square, where R is the radius of the earth. And then substitute the values. G means the gravitational constant. The value is 6.673 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. And M is the mass of the earth, 6 into 10 raised to 24 kilogram. And capital R is the radius of the earth, 6.4 into 10 raised to 6 meter. Substitute here and you will get the value of G is equal to 9.8 meter. The value of G is equal to 9.8 meter second raised to minus 2. Okay, so we already studied equations of motion. We have three equations of motion. V is equal to U plus AT. S is equal to UT plus half AT square. And V square minus U square is equal to 2AS. If the motion is under gravity, if the motion under gravity only, then we have to replace this acceleration with a small letter g, where g is the acceleration due to gravity. So equation of motion under gravity, the equations of motion under gravity becomes V is equal to U plus GT. You just replace this acceleration with the acceleration due to gravity. That is the equation of motion under gravity. So S is equal to UT plus half you should replace this a with g, so gt square. Then the third equation, v square minus u square is equal to 2. Replace this a with g, acceleration due to gravity. So these are the three equations of motion under gravity. So problem 9.2, a, a car falls off a ledge and drops to the ground in 0.5 seconds. So time is given data. Time t is equal to 0.5 seconds. So a car falls off a ledge and drops to the ground in 0.5 seconds. Let g is equal to 10 meter second raised to minus 2. So we know that the value of g is 9.8, but for simplifying the calculations, I am taking g as 10 meter second raised to minus 2. What is the speed on striking the ground? We should calculate what is the speed. Second one, what is the average speed? So first one is what is the speed on striking the ground? Second one, what is the average speed? And the third one, height. How high is the ledge from the ground? That means height means distance. We have to calculate the distance. So first of all, we have to calculate speed, then average speed and height. So in this case, I'm using the first equation of motion. I'm using the first equation of motion. What is the first equation? V is equal to u plus at. And here we are considering the g. So we should write the equation as v is equal to u plus gt. Okay, we are considering the gravitational acceleration due to gravity. So that means v is equal to u plus gt. So the first question is, what is the speed? Speed means velocity. What is the final velocity? So v is equal to, here the initial velocity is 0 because a car falls off a ledge and drops to the ground. So we can take the initial velocity as 0. So u is equal to 0. So v is equal to 0 plus the value of g is 10 into time is 0.5 seconds, 0.5. Tell me what is the value of v? 5 meter second. So v is equal to 5 meter second raised to minus 1. Then next is the second question is average speed. So second question is average speed. Average speed is equal to initial speed, initial velocity plus final velocity divided by 2. Tell me what is average speed? Average speed means initial speed plus final speed divided by 2. So this is equal to initial speed is 0. So 0 plus v is 5. So 0 plus 5 divided by 2. If you have two numbers, and how you will take the average, just add the two numbers and divide it by 2. That will be the average. U plus v divided by 2. So the answer is 2.5 meter second raised to minus 1. And the third part means what is the height? How high is the ledge from the ground? So how high means you have to find the distance. High means height. Height means distance. So you can use the second equation of motion. S is equal to ut plus half at square. But here you are using the acceleration due to gravity. So S is equal to ut plus half gt square. S is equal to ut plus half gt square. So S is equal to, so u is 0. So 0 into t plus half into g is 10 into time is 0.5 square. So that is equal to 1 by 2 into 10 into 0.5 into 0.5. So S is equal to 1.25 meter. So the answers are, so these are the answers. So it's speed on striking the ground. That means final velocity. Final velocity is 5 meter second raised to minus 1. And the second one is average speed. Average speed is 2.5 meter second raised to minus 1. And finally, distance. Finally, distance is equal to 1.25 meter. Then next problem, 9.3. Example 9.3. So here, this is the Earth. This is the surface of the Earth. So from here, an object is thrown vertically upwards. For example, this is the object, and this object is throwing vertically upwards. That means with an initial velocity u. So an object. So I'm throwing an object upwards with an initial velocity u. So after some time, it will reach a particular point. At that point, v is equal to 0. Final velocity becomes 0. Then it will fall back to the surface of the Earth. So there is a change in velocity. So there is a change in velocity means acceleration will be there. So acceleration, we know the equation acceleration is equal to v minus u by t. Here final velocity is 0, initial velocity is u. So there is a change in velocity, so acceleration will be there. And here I am throwing the object upwards. Okay, and the height is given. The object reaches a height of 10 meter. So the object reaches a height of 10 meter. So calculate the velocity. What is the velocity? Velocity with which the object was thrown upwards. That means initial velocity. What is the initial velocity? Because you are throwing this object, with an initial velocity. You are throwing this object with an initial velocity. So you have to calculate what is the initial velocity. And the second question is time taken by the object to reach the highest point. So what is the time? What is the time taken to reach the highest point? So first of all, you can write the third equation of motion. What is the third equation of motion? V square minus u square is equal to 2gs. So write the equation. So here you are calculating what is the initial velocity. That means you are calculating u. Final velocity is 0. And here, what is the acceleration? So the acceleration is here, the final velocity is 0. Initial velocity is there. So here, final velocity 0 means acceleration will be 0 minus initial velocity. That means this v is 0 and u is a big number. So 0 minus big number means the value will be negative, right? So acceleration will be negative. So the acceleration you have to take minus 9.8. We know that acceleration due to gravity is 9.8. Here you are taking acceleration as minus 9.8. Why acceleration is minus?
Acceleration is negative.
Yeah, acceleration is negative. Acceleration is equal to minus 9.8. So substitute here. So 0 minus u square is equal to 2 into minus 9.8 into s. So what is s? S means the distance. Okay. So the object reaches a height of 10 meter. So s is equal to 10 meter. So s is equal to 10. So 0 minus u square is minus u square is equal to minus 2 into 9.8 into 10. So this minus cancel. So u square is equal to 2 into 9.8 into 10. So u is equal to square root of 2 into 9.8 into 10. So initial velocity. So that means u is equal to 14 ms raised to minus 1. So that means you are throwing this object with a velocity of 14 meter per second. So I am throwing this object with a velocity, with a speed of 14 meter per second, and it reaches at this point. And then next is you have to calculate what is the time. What is the time taken by the object to reach the highest point? So how much time? How much time this will take to reach the highest point? So you can write the first equation. First equation of motion, v is equal to u plus gt. So v is equal to u plus gt. So v is equal to 0 because the object reaches here. The final velocity will be 0. So 0 is equal to u is 14. 14 plus g is 10. So no, here the g is 9.8. So minus 9.8 into time. So I can write 14 is equal to 9.8 into t. So I'm shifting this minus 9.8 to the left side. So it will becomes plus, right? So 9.8 into t is equal to 14. So t is equal to 9.8 divided by 14. So tell me what is the answer? So t is equal to this 9.8 here. So 14 divided by 9.8. So t is equal So using the equation v is equal to u plus gt. V is equal to 0, u is equal to 14, g is equal to minus 9.8, and t is equal to t. Then shifting this minus 9.8 t into the left side. So 9.8 t is equal to 14. So t is equal to 14 divided by 9.8. So when you divide 14 divided by 9.8, the answer is 1.4285, etc. like this. So here I am taking the first two digit only. Then I am canceling the remaining digits. So this is 8. So I am taking 1 from this and add this one with the 2. So this will becomes 1.4, 2 plus 1, 3. Then I can remove the remaining digits. So the answer is 1.43 seconds. So the answer is, so time taken. So this much time taken by the object to reach this height. So when you throw an object with an initial velocity of 14 meter per second, after 1.3 seconds time, it will reach here. It will reach the highest point, and then it will fall back to the Earth surface. That is the meaning of this. So you are throwing an object with an initial velocity of 14 meter per second. It will reach a certain height, and at this time, 1.3 seconds. Within 1.3 seconds, this object will reach here. Then it will fall back to the Earth's surface because of the acceleration due to gravity. So the answer is 1.43 seconds. So time taken is 1.43 seconds. So next question number 13. Solve this problem. Question number 13. So this is the Earth, and here I am throwing a ball. I am throwing a ball. A ball is thrown vertically upwards. I am throwing a ball vertically upwards. So to throw a ball, we need a velocity, right? That means initial velocity. So initial velocity is equal to 49 meter per second. So I'm throwing a ball vertically upwards with an initial velocity of 49 meter per second. So after some time, the ball will reach a certain height. Okay, so this is the height. After some time, the object will reach a certain height. So at this point, final velocity is equal to 0. I'm throwing an object with an initial velocity of 49 meter per second. I'm throwing an object with an initial velocity of 49 meter per second. Then after some time, it will reach here. The object will reach here at this point. So at this point, the final velocity will become 0. So you have to calculate what is the height, what is the maximum height to which it rises, and also the total time it takes to return to the surface of the earth. What is the time? So you have to calculate what is the height, h, and the second one, what is the time, the total time it takes to return to the surface of the earth. So how much time this object will take to reach the surface of the earth. So this time, this much time you have to calculate. How much time this object will take to return to the surface of the earth. So how you will calculate? You can use the second equation. Sorry, not the second equation, third equation. You can use the third equation. So what is the third equation of motion? V square minus U square is equal to 2gs. You can use the third equation of motion. V square minus U square is equal to 2gs. Here, final velocity is 0. So 0 minus initial velocity is 49. So 49 square is equal to 2 into. So here I am throwing this object. So that means acceleration. Acceleration is 9.8. 2 into 9.8 into s. What is the value of s? (49 square) is equal to 2 into 9.8 into s. So what is the answer? Minus 49 square is equal to 2 into 9.8 into s. Here, what is acceleration? Is it positive or negative? Minus, right? Yeah. Because the equation of acceleration, what is the equation of acceleration? V minus u divided by t. Here, final velocity is 0. Initial velocity is 49. So 0 minus 49 means acceleration is negative. So acceleration is minus 9.8. So this minus minus cancel. So 49 into 49 is equal to 2 into 9.8 into. I am replacing this s with the h because we are calculating the height. So I'm replacing this s with the h. So h is equal to 49 into 49 divided by 2 into 9.8. So H is equal to, so for 49 into 49. So 49 into 49 is 2401, 2401 divided by 9.8 into 2. 9.8 into 2 is 19.6. So here one decimal. To change this decimal, I will multiply with 10. So to cancel this 10, I will multiply 10 in the numerator also. So this will becomes 24010 divided by 196. So when you divide this, you will get 122.5 meter. So the answer is 122.5 meter. When you divide this to 24,010 divided by 196, the answer is 122.5 meter. That means this height is 122.5 meter. So I am throwing a ball. I am throwing a ball with an initial velocity of 49 meter per second. It will reach a height of 122.5 meter. So the object will reach. So I'm throwing a ball. I'm throwing a ball upwards with a velocity of 49 meter per second. It will reach this height. So the height is 122.5 meter. The ball will reach 122.5 height. So the second part is, what is the total time it takes to return to the surface of the earth? So you can use the first equation of motion. So V is equal to U plus GT. So write the first equation of motion. V is equal to U plus GT. So final velocity is equal to 0. 0 plus 40, U is 49. 49 plus G is minus 9.8 into T. So I'm shifting this minus 9.8 T to the left side. So 9.8 T is equal to 49. So T is equal to 49 divided by 9.8. So to change this decimal, I have to multiply with 10. So into 10 by 10. So tell me, what is the value of time? So T is equal to 490 divided by 98. T is equal to 490 divided by 98. So time T is equal to 5 seconds, right? So what is the meaning of this? So time T is equal to 5 seconds. See, I'm throwing a ball with a velocity of 49 meter per second. It will reach a height of 122.5 meter in time 5 seconds. In time T is equal to 5 seconds, the ball will reach a height of 122.5 with an initial velocity of 49 meter per second. But here the question is what they asked. The second part. The second part is the total time. You have to calculate what is the total time. The total time it takes to return to the surface of the earth. Okay. So total time means you have to calculate what is the total time. So here I have calculated the time, right? To reach this ball from the surface of the earth to this height. But here they asked to calculate what is the total time it takes to return to the surface of the earth. So this is the starting point A. It will reach here, then returns back to the final position. That means this is 5, then return also 5. That means total time is equal to 5 plus 5. So the answer is 10 seconds. So this time is from Earth to this height, 122.5. The question is, what is the total time it takes to return to the surface of the Earth? That means from here, from the Earth to this height, then returns back to this point. That means this is 5 plus the next 5. So that means the answer is 10 seconds. Then question number 14. So next question is question number 14. This is Earth. So here, this is the object, stone. This is stone. A stone is released from the top of a tower of height 19.6 meter. So that means this height is 19.6 meter. This height is 19.6 meter. So this stone is at a height of 19.6 meter from the surface of the earth. So a stone is released. So now initially the stone is here. That means u is equal to 0. Initial velocity equal to 0. Then I released this stone. That means it will reach a final velocity. Okay. So initially the stone is here. At that point, initial velocity is equal to 0. Then I release this stone. It will reach to the surface of the earth with a velocity called final velocity. So calculate the final velocity before touching the ground. So we should calculate what is the final velocity before touching the ground. Before touching the ground, what is the final velocity? So we can write the first equation of motion. V is equal to u plus gt. V is equal to u plus gt. So here v is equal to, what is the initial velocity? 0 plus g. G means acceleration due to gravity. So here we know that acceleration is equal to v minus u by t, right? Here initial velocity is 0. We have a velocity. That means the sign of the acceleration due to gravity is plus. So this will be plus 9.8 into time. Time is, what is time? No, you can't use this equation because there is no time here. So you can't use this equation. So we can use the third equation. So the third equation is v square minus u square is equal to 2gs. We can use this equation. So v square minus 0 square is equal to 2 into 9.8 into s. S means this distance, this height. This height is 19.6. So v square is equal to 2 into 9.8 into 19.6. So v is equal to square root of 2 into 9.8 into 19.6. Tell me what is the answer of v? So final velocity v is equal to 19.6 meter per second. So when you solve this, final velocity v is equal to 19.6 meter per second. So question number 15. A stone is thrown vertically. So draw the figure, earth. So this is the stone. So this stone is throwing vertically upwards. So to throw this stone, we need a velocity that is called initial velocity. So the initial velocity is 40 meter per second. With an initial velocity of 40 meter per second, this stone is throwing upward. So after some time, this object, this stone will reach here. Okay, at this point, final velocity is equal to 0. At this point, final velocity is equal to 0. So take g is equal to 10 meter per second square for to simplify the calculations. Find the maximum height reached by the stone. You have to calculate what is this h. What is the maximum height? Find the net displacement. We have to calculate what is the displacement. Net displacement.
So net displacement. So calculate the next net displacement. Calculate the net displacement and the total distance covered by the stone. Next is distance, total distance. So we have to calculate what is the height. What is the height? Height means this distance from Earth to this point, this particular point. And what is the net displacement and what is the total distance? First, we will calculate this height, the maximum height. So you can write the third equation. What is the third equation? V square minus U square is equal to 2gs. So final velocity is 0. So 0 minus 40 square is equal to 2 into, here I'm throwing this stone upwards. So acceleration will be there. So that will be minus 10 into S. So S means this distance. So this much height, this stone will reach. So that means S will be H. So this minus cancel. So 40 square is equal to 2 into 10 into H. So H is equal to, this will come here. So 40 into 40 divided by 2 into 10. So H is equal to 80 meter. Okay. So next is what is the displacement and what is the total distance covered by the stone. So this, from here I am throwing this stone upwards, right? So the stone reaches a height of 80 meter, right? So the stone will reach here, then it will return back to the same position. That means
160 meter.
no. Yeah, that is the total distance. So total distance is equal to 160 meter. So 80 plus 80, that means the stone will reach here. So this distance is 80, then returns back to this position. That means 80. So 80 plus 80, that is equal to 160. That is the total distance. Then next is calculate the displacement. So displacement, you need an origin, reference point. So this is my reference point. This is my origin. So the ball starts from here and it reaches here and then returns to the same position. That means this is the origin and this is the final position. So displacement means the distance between the final position and the initial position. So displacement is equal to what? So here displacement is equal to 0. Displacement is equal to, here displacement is equal to 0. Why displacement is equal to 0? Because this is my origin. The stone, I'm throwing stone from here. The stone will reach here, then returns back to the same position. So to define the displacement, we need an origin. So this is my origin. Okay, and this is my final position. So if the origin and final position same, then the displacement is equal to 0. Then the displacement is equal to 0. So the answer is, so net displacement is equal to 0. So question number 16, calculate the force of gravitation. Universal law of gravitation, we know the equation. F is equal to capital G into capital M into small m divided by d square. So calculate the force of gravitation between the earth and the sun. Okay, and for example, I'm writing this as earth and this as sun. So me into ms. That the mass of the earth 6 into 10 raised to 24 kilogram and sun 2 into 10 raised to 30 kilogram. Distance is given, so I can write F is equal to G. What is the value of G?
6.7 into 10 raised to power minus 11.
6.673 into 10 raised to minus 11 into mass of the earth 6 into 10 raised to 24 into mass of the sun 2 into 10 raised to 30, the whole divided by distance is 1.5 into 10 raised to 11 into 1.5 into 10 raised to 11. So F is equal to 6.673 into 6 into 2 into, this is 10 raised to minus 11 into 10 raised to 30. That means a raised to m into a raised to n. So 30 minus 11. 30 minus 11. So 9, 19. Then 24. 24 means 9 plus 4. On balance 43, right? So this is into 10 raised to 43 divided by 1.5 into 1.5 into 10 raised to 11 into 10 raised to 11. That means 10 raised to 22. Then a raised to m by a raised to n is equal to a raised to m minus n. So this is equal to 6.673 into 6 into 2 divided by 1.5 into 1.5 into 10 raised to 21. So when you multiply numerator, you will get 80.076 divided by 1.5 into 1.5. That means 2.25 into 10 raised to 21. So when you divide this, we will get 35.58 into 10 raised to 21. So this is force, the unit is in Newton. So 35.58 into 10 raised to 21 Newton. Or I can write 35.58, I'm dividing this with the 10 into 10 into 10 raised to 21. So when I divide this 35.58 by 10, so this decimal will be shifted to the left side, one digit. So that means 3.5. So 3.5 into 10 raised to 21 into 10, that means 10 raised to 22 Newton. So the answer is 3.5 into 10 raised to 22 Newton. That is the answer. 3.5 into 10 raised to 22 Newton.